Welcome to CS150 scripting. We have a recording today. We're doing things a little bit differently. And then instead of having face-to-face, Dr. Donald will be taking my place. Just in case I'm recording this, you may use this to basically as a support for having the class today. But again, so I'm recording it. We're going to go through the same process we normally do within class and cover the same points. So right now we're going to be talking about the unit overview. Should be able to see the screen overview. This week we're going to doing a comparative analysis of very scripts, scripting environments, PowerShell. I hope you know what that is. Bash, VBS script, and batch scripting, or BAT files. We're going to explore differences, strengths, limitations, weaknesses. We're not going to in this week and learn a new scripting language or learn Bash. It won't be a video script, but we will be taking and looking at the characteristics, the high-level characteristics of each and how they compare with each other, and where one might have an advantage over the other. Okay, so our learning objectives for this week 6 is by the end of the week, I would like to be able to compare PowerShell to Bash scripting syntax, explain the purpose of Bash shebang, identify differences between object-based and text-based shells, describe the role of cron in Linux automation, explain how VB scripts, and batch scripts were historically used. Evaluate when to use PowerShell and other scripting languages. And basically on a high level, to analyze the strengths and weaknesses of each scripting approach. So this is more of a high level comparison than a deep dive into the syntax of each scripting environment. So just kind of let you know that basically this is more of a comparison. Familiarize yourself that there are other scripting environments out there that we can be used, and that basically by the end of this week, you're going to find out that it's an advantage for you to learn multiple scripting environments and syntax. Okay, so that's our environment, general text environment. Next, we're going to delve into our definitions as far as what are the key terms that we're going to follow and understand as far as it states that these are definitions that I want you to learn so that you won't be spending as much time on trying to figure out what they are, but more concentrate on how you can use them. Okay, so let's delve into our key terms that we're going to be approaching and working with on week 6. So the key terms are these. We have Bash, it's a command line shell commonly used in Linux and Mac OS systems for running commands and writing scripts. Linux shell scripting, writing scripts that automate tasks in Linux using shell commands and tools. VB scripting language historically used in Windows for automation and for administrative type tasks. Legacy Windows automation, older scripting method used to automate tasks on a Windows system before PowerShell came to be common. There's probably a few still out there being used on older Linux systems, on older Windows systems that may very remotely be using VB script, but probably won't be many of them. Now, legacy Windows automation, older scripting methods used to automate on Windows systems before PowerShell. Okay. Batch scripting, a type of scripting used in Windows command prompt to automate tasks using command line instructions. And then we have bat files, batch script files that contain a series of commands executed by Windows command interpreter. Shebang, okay, is on the Linux side, a special line at the beginning of the script that's going to tell the Linux system which interpreter should be used to run the script. Example of that shebang is in the pound exclamation point /bin/bash. This is basically at the beginning of the script. Common shebang line tells the system to run the script using bash shell. It can also be as ZHS. And so this is the syntax. And again, just for high level comparisons that I'm looking for you to kind of understand, everything doesn't look like PowerShell. Object-based shells, shell environments like PowerShell that work with structured objects instead of plain text. That's one of the key features of PowerShell, where object being not only does it have the characteristics of the class, but also the methods that should be associated with that class or with that object. Okay. Text-based shells, shell environments like Bash that pass plain text between commands rather than objects. And then cron is a scheduling tool in Linux used to run scripts or commands automatically at certain times. So it's basically the Linux side, the scheduler part on the Linux side. In your homework assignment, you are going to have to look into PowerShell scheduling features. And so you will have an understanding of how this compares to the PowerShell. Okay, so those are our basic terms that we have for week 6, okay, as far as doing this high-level comparison of scripting environments. And so with that, we're ready to move on to our other next set, which will be looking at the homework assignment. Okay, so here we are as far as what the kind of review of the homework assignment. As usual, any questions you have on what is being asked for, let me know. Even though the first thing I'm expecting you to do is kind of our cardinal rule, is kind of look it up and give yourself a chance to do some research, and in order to answer questions that you might have. If during that research you cannot find something that will satisfy your answer, get with me, and then we'll work through it together to make sure that you understand what's being asked for. So here we have the homework assignment. We're analyzing and comparing the equivalent scripts written in different scripting environments. Part A, we're doing a syntax comparison. So I want you to research and compare PowerShell with batch or the BAT files. I want you to complete a comparison table, as described below, where we haven't talked about the features of variable syntax, loop syntax, conditional syntax, schedule tool, object, or whether it's object-based or text-based. And we're going to be doing that for PowerShell, Bash, and Batch. So I want you to fill in the information for these 3 scripting environments based on these features. And I want you to submit it as a formatted document. Okay, so something a little prettier than this. This is what I want. I want you to spruce it up. Okay. Part B, script conversion. Given the following batch script, okay, I want you to do some research on what this is actually asking Linux scripting environment to do. Based on those requirements, I want you to write the equivalent PowerShell script. Then once you write the PowerShell script, I want you to convert the PowerShell script into a simple batch or BAT script, where we're writing host system information, getting date, and getting the PS drive, and basically looking at what we did in PowerShell. Part C, the cron scheduler in Linux versus the scheduled task. I want you to research understanding kind of the high level of cron, and then the registered scheduled task from PowerShell. Okay, so what I want you to do is look at the similarities between them, look at the differences, which is more powerful and why. Again, from a high level, looking at the scheduling that's being done with cron on Linux versus the scheduling that's being done in Windows with PowerShell. In Part D, Has basically some reflection questions, not looking for a book, 10 to 12 sentences, answer, why does Microsoft move away from VB why is PowerShell more suited for enterprise environments? And when might Bash still be preferable over PowerShell? Okay. And so do some research on that and provide those answers. So in submission, the comparison table, the script conversion, and the reflection questions are the homework assignment that are expected for week 6. Okay, as far as the project lab, we're still working with, as we've been over the last 5 weeks, looking at the system health audit tool that we're putting together. Today we're going to be focusing on modular construction, remote target, structured output, and logging. The goal, and we're building this week, converting your week 1 through 5 audit script into a professional tool that can run against local or remote computers. Produce clean, structured output using logging system based on the logging level, warn, severe, and info. Export the reports that basically you'll be building into CSV, TXT, and HTML formats, similar to what we did in week 4. Student instructions for this. I want you to create your final script. This is your system audit tool. In your system audit tool folder, I want you to create the system audit tool, .ps1. This is the final tool, not a week 6 version. This is where we're basically making sure that we have everything we did from 1 through 5, and we're putting it together into a solid object that can be delivered. Okay, required parameterization, all parameter blocks that support remote target selection. We want to add that. The required parameters are identified here and what the defaults are. Okay, so reading that, include those parameter types. Requirements, script must run with no parameters. Okay, if a remote computer is provided but not reachable, tools must log errors and exit cleanly. And this basically applies that we're at the point where the checks that you make or the error messages you should put out. So this is a situation where there shouldn't be a situation that you're getting an error and you haven't processed for it. Okay. That you're basically going to let the system crash. So that this here, cleanly, no crash, is a no-no. If looking at your scripts, you're going to be looking at the pieces and the process you're doing and seeing that is there a need for, for example, logging? Do I need info? Is it a warn? Is it an error? Am I debugging? Okay. So all this stuff I'm expecting you to put in, look at your script, seeing where it can fail, and making sure that you have the code in there, the logic in there to be able to capture those possible errors. In number 3, we're going to turn the script into a modular tool. Your script must be organized into functions. Here's the minimum set below. Everybody knows what a function is. Okay. So, write log, this is text summary, disk health, critical service health, failed logons, analyze log, and export audit reports. These are basically the functions that are going to be or should be in place in your script at this point. And again, really nothing new as to what we've basically been doing over weeks 1 through 5. So we're taking that and basically making sure we put it together into a concise scripting object. Number 4, remote computer support required. Your tool must accept the computer name and attempt to collect info from that computer. Minimum expectation. You can implement remote support to either way. Here is recommended. It's basically using PowerShell. PowerShell remoting, the invoke command. If remote isn't enabled, then you must catch the error, log it, tell the user how to run it locally as a fallback. Option B, which we No, I'm putting it in here because it's just from a research point of view, there's other methods other than PowerShell that you can basically be using. Okay, so we have a CIM, WIM calls. Okay, get CIM instance. Research that. Okay, research that and see, what it's going to take for you to implement maybe option B rather than option A. Maybe easier. That's one of these. Let's see what it shows based on your research. Required behavior, if the computer name is remote, include the target name prominently in the report header, log a connection and attempt result. If it fails, write failed to reach whatever the computer name is in the console, log the error and exit cleanly. That's the key thing I'm looking for. Clean, soft landings. Clean structured output instead of printing a random command output, system.out. Your tool should build a single structured result object, which basically has the reporting, the alert summary, the disk health collection, the service health collection, and basically building that. And we've gone through homework assignments where we were actually building this combined object, which contains all the information I want for our particular tool. Okay, and required overall status, commute the status. If any disk warnings or alerts exist, attention is required, should be printed out. Otherwise, give the user an all clear. Everything's fine. Logging, we do want to implement logging. Tool must generate a log file per run. Audit log, computer name, timestamp.log. Basically is where we're going to be putting the information for the logging process of what we've been processing. So logging must include the tool start, parameters used, target computer and collection status, any warnings or alerts found, exports success messages, any errors, including stack exception messages. Just again, looking your code and anywhere you say, well, I might have an error there. Okay, you might want to do a try or try with resources. Yeah, so we're going to talk. The expectation is there is to have a clean script at this point. Okay, so that's an explanation of the homework assignment and an explanation of what we're looking for the project for week 6. Okay, now we're ready to delve into and do the deep dive into the nitty gritty guts of what we're looking at as far as the comparison of these scripting environments. So here we go, cross-platform scripting environments. We're asking, do all operating systems use the same scripting tool? And obviously that answer is no. The scripting tool that's used is going to be based on the environment. And the ones that we're basically going to look at from a high level today or this week is PowerShell, Linux, Mac, and batch files. More specifically, the Linux, and the batch. Okay, different systems use different shells and different languages, but they all serve the same goal. Okay, that's was to track their system processes, being able to monitor, what is happening in the environment, who is doing what, and basically being able to provide reporting for what's happening in the system. And so whether that's PowerShell, Linux, batch, the purpose is the same as far as what we're doing. Even when it comes down to automation tasks, when do we want something to run? What do we want to run? Okay. So that's basically what we're describing down here. And it basically is saying, this is what I want to do regardless of my scripting environment. Different syntax, but the same requirements of what we're looking for. So the basic component, we kind of define this in the definition. What is a shell? A shell is a program that allows users to interact with the operating system using commands. Obviously, with PowerShell, we've gone through several of those as far as the commandlets, okay, that we've basically been using to ask for information. Okay, so what is expected from as far as objectives. Okay, my expectation is you'll be running tasks in the background using start job, monitoring jobs using get job, retrieving results using receive job, and managing jobs stop and remove. So here's the basic PowerShell items that we're going to be using. Okay. Okay, so we'll be utilizing some of those functionalities that we did have in week 4. From an operating systems perspective, Windows, Linux, Mac, PowerShell, Bash, Mac OS also uses Bash and Zish. The shell allows user to run commands, execute scripts, automate tasks. So what we're doing for PowerShell, just picture that we can do the same thing: run, execute, automate, and manage, but in a different environment. Okay, in a Linux environment, in an Mac OS environment. And same languages. Think of it that you're basically C++ has certain syntax, certain ways we do things, which is different from what we do for Python, which is different from what we do for any other object-oriented programming. But what we're doing doesn't change. How we're doing it is changing. So that's what's basically being said here. What we need to do hasn't changed. We're just going to change the syntax. There should be a way, and as we looked at it in the homework assignment, that I can take some code that's in Linux and basically take that and convert it to a PowerShell command. I can take the PowerShell and convert it to a .bat file, but the functionality is still going to be the same. So here, an example, we have ls, which is basically being used on Linux. It says list files that are in the current directory. Here's just for visibility. This is your good old hello world and how we would implement that in a Linux environment. Okay, here the shebang. Okay, here says I want to run this in the bash environment. It tells the system to use bash, and then echo says print out hello world to the console. So the line at the top is a shebang, okay, which is defined here. Okay, so shebang, script execution. Shebang is the first line of any script. Okay, same example. It tells the operating systems use bash interpreter to run the script. It's a given in that if I don't do that, then when I'm running this, attempting to run this in Linux, it's basically going to say, hey, I don't know what environment you want me to run this through. And again, that's because especially in the case of Linux, there are older versions of a scripting environment that can still be used. Okay, so you have to specifically tell Linux what you're planning to do. So running a bash script, the steps, we're going to create a file, for example, here script.sh, make it executable, cmod plus x script.sh, and then run it /script.sh. And again, the thing that I want you to get across, am I concerned that you know exactly what the syntax is looking at, what the syntax is saying? No. I am, though, saying that if I had created a PowerShell program, a PowerShell script, and it's basically doing these items, that you should know that each one of those items I'm doing in PowerShell has a corresponding, version in Linux, or a corresponding version in Mac OS. Okay, or I can do a BAT file. Okay, so there is a comparable, basically, bridge from PowerShell to another scripting language. So that's what I'm highlighting here, just that the process, okay, and the syntax, okay, is basically the same, but why I'm doing it and what I'm trying to get is really the same as what I did in PowerShell. Okay, batch scripting in Windows. This is the .bat version. It was here before PowerShell is what administrators use to run scripts. And basically they always ended in .bat. Example, backup.bat. Example here, echo would say backup starting, list the directory, and then finish. Syntax. Okay. Basically, what am I want to do? I want to get the content of a directory. I can do that in PowerShell. I can do that in Linux with Bash. Just the syntax on how we do it is different. What we're going to do is still that capability is there. A bash scripts run inside the command prompt. Limitations of bash scripts. Scripts are text-based. Okay. PowerShell is object-based. Limited in features and harder to maintain. This is basically saying PowerShell will eventually replace them because of, you'll see later, we're talking about being more powerful than your typical scripting environment. Okay, VB script, legacy automation, and kind of one of the old guard. VB script was another scripting language used by older Windows systems. Often used, it's often used by system administrators, login scripts, Windows automation. Some examples here, good old hello world, we're going to do a message box. In the message box, we'll take that VB script and write it to the terminal. But here, Microsoft has largely replaced VB script with PowerShell. Not to say that there aren't any VB scripts out there remaining by some businesses, depending on the need or the desire to be currently up to date. They might have moved it up to PowerShell, probably with various environments and upgrading that happen. But there may be that possibility that that VB script is still used and you will be able to see it. Okay. Object-based versus text-based shells. Okay, text-based shells, examples, bash and bat uses plain text. Okay, here, list the directory and put it out on a greport.txt file. We did a lot of this as far as taking reports, putting them out on various files, and being able to import or export them, again, basis whether they're CSV, text, or HTML. Okay, so we talked about this. This is the plain text version of what we're doing with those objects in PowerShell. Okay, key thing here. Okay, the reason the text files are such a pain is they have to be parsed. They have to be looked at and pieces taken out. Here, if I had a text, I have to parse out the ls. Okay, I have to parse out the file. Okay, okay. I have to I get to parse out the pipeline. Okay, the bar. And then once I break this out, then I can figure out what I need to do. Okay. In the case of PowerShell, I have an object. I don't need to do that parsing. In the object are the characteristics of that particular object, the fields that apply. In that object are the methods that are used on what that particular object can do, what that particular object can produce. Okay. Excuse me. I don't have to parse anything out. But with text, I do. So that's one of the big things that programs must parse text that's passed back and forth with the various scripting modules that you don't have to do with PowerShell. And this is just that object-based shells, PowerShell, commands pass objects instead of text. Here we're getting a process, getting objects from current processes, and basically looking for any one that has a CPU value greater than 50. And structured data within the object, easier filtering, more reliable scripting. Those are the basic differences between an object-oriented, object-based shell, object-oriented, or a text-based shell. Scheduling automation with Chrome. Chrome, again, is the scheduling tool for Linux. Okay. We also have the scheduling tool for PowerShell. This is basically, Chrome allows scripts to run automatically at scheduled times. All scripting shells basically do the same. There is a scheduling component. So here we can do daily backups, we can do system maintenance, we can do secure scans. Here is an example from cron job we're using, and this runs the script every day at 2 a.m. Okay, that's the syntax. Again, I'm not really up to or getting you to say, okay, I want you to know what that syntax is. Know what it does. Know that there is, if I have a job, I can ask the question, I need to schedule a job to run every day at 2 a.m. I go ahead and do my research. If I am in a Linux environment and I'm using Chrome, okay, I know that I can go find the syntax. That's how I do that. How do I schedule that? So I'm more concerned with you have an issue, you have a problem, doing the research that says, okay, how do I solve that problem if I was in PowerShell? How would I solve that problem if I'm in Linux? Okay, so taking that information and using that as a basis for your research. Okay, so in the final comparisons, what we have is the features, okay, data type, platform, automation, power, and modern use. From Bash, the data types text, Linux, Mac OS, okay, uses Bash. Automation power is strong as far as using it in the Linux environment. And modern use, yes, it is still used today. Batch, okay, we have a data type text, Windows, limited automation power, limited use. Notice it didn't say no use. Okay, so these things are still useful and used in a business environment. PowerShell uses objects, not text. Windows are cross-platform. Okay, can have PowerShell in other environments other than Windows. Very powerful. Yes, it's definitely modern use today, as you can attest. So the final takeaway, organizations run multiple operating systems. I presented you the class that scripting or system administration is a career. Okay. So it is there to say, yeah, it's not writing programs, it's not writing games, but you can get a lucrative job in administration and managing building scripts over multiple systems. So maybe your next class you'll take a Linux class on scripting. It's best to learn as much as you can. Being that you have PowerShell, you've learned, the basics of what can be done, what can be tracked, what you can do, what can be reported. Now it's a matter of not just taking that information, the what you can do, taking that and maybe getting in Linux and say, well, how would I do this in Linux? How would I do this on Mac OS? I know what I can do because PowerShell basically drove me into understanding the possibilities of what kind of information I can get out of the system. Now I'm in the case where I know what I can get out. What is the syntax do I need to change? So look at this from a high level of, applying what you have learned from PowerShell, and at least at a minimum know that what are the possibilities that you can do in other scripting environments. Okay, organizations often run on operating systems. System administration developers must understand different shells, different scripting environments, how automation works across platforms. PowerShell is powerful, but understanding of Bash and other scripting languages makes you more versatile, aka makes you more important. Okay, so that covers basically what we would have talked about if I was face-to-face with you. Again, any questions, any problems, please give me a call. Our rule, though, as you know, is if I have a question about something, look it up, because when I get into the real world environment, there are going to be times when you're going to need to learn how to do something, maybe not quite sure. You're not going to have an instructor necessarily that's going to be there, that's going to guide you. You might have to look it up, do some research, understand what's happening, and then take that, apply it, test it, run it. But since you're here at Carolina University, if for some reason you do that research and you can't find the answer, you don't understand it, definitely get with me, call me, text me, and we'll take a look at it and we'll solve it together. Okay, so have a great week 6, everyone, and we'll see you later.